Welcome back to my YouTube channel. Today I'm going to be talking about how to solve a system of linear equations using the elimination method. So as with the name elimination, basically we are trying to eliminate a variable, and I'm going to be showing you how that works. So first, what I like to do is I like to label my equations, okay? And then what we have to do for elimination is we are trying to eliminate one of these variables, either x or y, okay? Now, how we do that is we either subtract the equations, these two equations, like 1 minus 2, or something like 1 plus 2, like you add the equations. But before we can really do that, we really have to make sure that the coefficients of the equations, right, are the same. So, or like opposite in sign but the same number. So like, for example, here it's 9y, right, negative 9y, and this here is 3y, and we want to make it the same because right now it's different. So what we can do here is we know 3 times 3 gives us 9, so we can take this equation 1 and multiply by 3, and then when we multiply this by 3, right, if we do 3 times 3y, we get 9y. And if we get 9y, if we change this to 9y, then it's going to be the same as this, and then we could basically add or subtract. Well, it's going to be adding because we know 9y minus 9y is going to give us 0y, so 0, right? So we're trying to eliminate y now, okay? You can do it for x, but we're going to stick to y because it's easier. We could just multiply equation 1 by 3. So I'm going to take equation 1 and I'm going to multiply by 3. So multiplying equation 1 by 3 means I must multiply both sides by 3. So writing this out, I have here equation 1, right? 7x plus 3y was from here. And then I have 6 here, right? And I basically took both sides and I multiplied by 3, right here and right here. So what we have to do now is we have to use the distributive property here. And we distribute this 3 to each one. So 3 times 7x is going to give us 21x. 3 times 3y is going to give us 9y. And then 6 times 3 is going to give us 18. And here we have our next equation. And here we can name this as equation 3. So we changed equation 1 into equation 3. So we can notice that in equation 2, right, in equation 3, we can basically add the equations together. We can eliminate 9y, negative 9y and positive 9y, because 9y minus 9y, as shown right here, right, positive 9y minus 9y is going to give us 0, right? So we can eliminate that. So how about we take equation 2 and 3 and we add it together? So we can take these two and add it together, and then we will eliminate y. So I'm going to do equation 2 plus equation 3. And I have here, I'm going to copy it, 5x minus 9y equals 11. This was our equation 2, right? And then we are adding this equation. We are adding this equation with equation 3, which I'm going to copy below. It's 21x plus 9y equals 18. This is our equation 3 that I copied from here, okay? So now from here we can basically add these equations together. So adding it together, we look at 5x and we add 21x, right? Because these are like terms, we can combine them. These are like terms, we can combine them. And these are also like terms. They are both constants, we can combine these. So 5 plus 21 gives us 26. And there's the x, so 26x. Now negative 9y plus 9y is going to give us 0, as mentioned before, right? So since that gives us 0, we can cancel these two, right? We don't have to write anything here. Okay, And then here 11 plus 18, that's going to give us 29. Okay, so 11 plus 18 gives us 29. 8 plus 1 is 9. 1 plus 1 here is 2. Okay, so now we are left with one variable, the x. And we know 26x is equal to 29. Now what we can do is we can see this is 26 times x, right? We want to isolate for x now. 26 times x, and the opposite of that is division. So we're going to divide both sides by 26. So divide this by 26, divide this by 26. And then this 26 and this 26 are going to cancel, and then we are left with x is equal to 29 over 26. Just like that. So now we have found our x variable. So now that we have found our x variable, we can basically plug what we have for x into one of the equations and solve for y. And basically solve for y. So how about we plug this into, it doesn't really matter which equation. I mean, if there was like a y that was being isolated already, then it would be easier to plug it in, but we don't really have that. So just plug it into equation 1. Yeah, why not? So let's plug this right here, x equals 29 over 26, into equation 1. So sub x equals 29 over 26 into equation 1. And the equation 1, we had 7x plus 3y equals 6. I'm just going to copy that. So 7x plus 3y equals 6, right? This is the same as this here, right? I'm copying it. Equation 1. So I'm just going to plug in this value into the x right here. So I'm just going to plug it right in here. So I'm going to get 7 times 29 over 26 plus 3y is going to be equal to 6. So from here, I can see that I can't really simplify this fraction, right? So I can just multiply it right away. Okay, so I'm going to do 7 times 29. And so from there, 7 times 29, I am going to get 203. This is over 26. And then plus 3y equals 6. So now from here, we are still trying to isolate for y, right? We are trying to isolate for y. We're trying to find y. We already found x. We're trying to find y. So we're just going to look at the side where there's all the y's. So this side we have the y, and we want to get rid of everything that's beside the y. We have two terms, 1, 2, right? So we can get rid of this term first. So the multiply by 3 we can deal with later. We have to deal with the terms first, right? Because it's separated by addition signs, and that is what we have to do first. So we're going to subtract both sides by 203 over 26. So doing that, I'm just going to copy this first. So I copy the same thing. I'm just going to take this and subtract it on both sides. And why do I subtract it? Well, 203 over 26, right? There's no sign here, but there's always going to be an invisible plus sign here. It's invisible, but you can write it, but usually it's not written, but we know that this is positive. And since this is actually positive, even without the sign, it just means that we subtract, because that's the opposite of addition. We do the opposite, and when we do the opposite, we must do it on both sides. So right here and right here, we apply it on both sides to balance out the equation. So now that we did that, we did the opposite, we can basically recognize this is going to give us 0, so we can cancel it. And then this is going to be 3y right here, and then it's equal to 6 minus 203 over 26. And then what we can do now is we can divide both sides by 3. So because we want to get rid of this 3, right, that's multiplied to the y. The opposite of multiplication is division. So I'm going to divide both sides by 3. So dividing both sides by 3, I do it here. And then here, I'm going to divide by 3. So dividing by 3 is just basically multiplying by a fraction of 1/3. So That's why I wrote 1 over 3. That's basically the same as dividing by 3 because the fraction just means division. So this 3 and this 3 are going to cancel, and then y is going to be equal to, well, we have to use a distributive property, right? Distribute this here, distribute this here. So 6 is going to be multiplied by 1 over 3, as shown here, right? And then minus 203 over 26 is going to be multiplied by 1 over 3. And then now what we can do is we see 6 times 1 over 3, and that's going to be basically the same as 6 divided by 3, so that's going to be 2. And then minus 203 times 1, which is just 203. And 26 times 3 is 78, so I'm going to write 78 here. And then now we have to simplify this and basically find y, so we can recognize that this 2 here is over 1. So since it's 2 over 1, we can find a common denominator for that. And to do that, we multiply the top and bottom, the numerator and denominator, by 78. So multiply by 78 and multiply by 78 right here. So we get the same denominator as the second fraction. So we do 78 times 2, and that's going to give us 156. And then the denominator, 1 times 78, is just going to be 78. And then we subtract 203 over 78. So 203 over 78. Now that we have the same denominator, we can basically just subtract it. So 156 minus 203 all over 78. So 156 minus 203, that's going to give you negative 47 over 78. And that's basically the same as writing the negative right here in front of the fraction sign. 47 over 78, just like that. And we have found our y. This is our y, right? And since we have found our y and our x right here, we can see that our solution, therefore our solution is x is equal to 29 over 26, and our y is equal to negative 47 over 78, as shown right here and right here. And we can express this as coordinates, so 29 over 26, comma, negative 47 over 78, like that. This is our x and this is our y, and there we have it. We have found the solution. And furthermore, I've actually found this solution using substitution in another one of my YouTube videos, so feel free to check that out as well, because there is a way to solve this using substitution. But of course, elimination is probably the preferred method in this case because it's a lot quicker. You can basically eliminate one variable and then you can solve for x. Substitution might not be the best case, but if you were actually being asked to solve it using substitution, then you would have no choice and you would have to do substitution. So there is a video explaining how to solve the same linear system using substitution, so feel free to check that out. So now say we have a question that looks something like this. So to solve this linear system, there are many different approaches. Just like before, we had different approaches. Many different approaches. We could either eliminate x or we could eliminate y, right? And so here we can't exactly, it wasn't like before where we could just multiply one of the equations and then it would match up with the coefficient of the other equation. Instead here, rather, we would have to multiply both of the equations. So we can choose to either eliminate y or x. And here in this example, I'm going to choose to eliminate x in this case. Doesn't really matter, but I think it's about the same level of work that you have to do. So I'm just going to choose to eliminate x. So I'm going to first label my equation. So this is equation 1, and this here is equation 2. So to eliminate x, right, what I'm going to have to do is basically make sure coefficient's the same. So here it's 5 and 2, right? And what I can do is I can basically see that, basically do 5 times 2, right? 5 times 2, I'm going to get 10. So basically I can take the first equation, I can multiply this by 2, right? Because 2 times 5x is going to give me 10x. And then I can take the second equation, multiply it by 5. So 5 times 2x is going to give me 10x. And hey, that's going to be the same, right? So that's ideally what we would like. So I'm going to take equation 1 and I am going to multiply it by 2. So equation 1 times 2. So I'm going to basically multiply by 2 for each of these terms. So what's 2 times 5x? Well, it's going to be 10x, as mentioned before, right here, right? So I'm multiplying by 2 times 5x, multiplying by 2 for each of the terms. So 2 times 5x gives us 10x. 2 times 2y gives us 4y. Okay, so we're multiplying it by each of these terms. And then negative 8 times 2 is going to give us negative 16. So that's basically the same as like multiplying each side by 2. So multiplying this side by 2 and multiplying this side by 2, because we would ultimately need to apply the distributive property into each of these terms. So it's the same as multiplying each term by 2. So now that we have done it for equation 1, we got this equation, this new equation we can call equation 3. Now we have to do something similar to equation 2, multiplying by 5, right? So I'm going to do equation 2 multiplied by 5. And remember, our ultimate goal is to get the x variable to be 10x for each of these equations. So for equation 2, we're going to multiply by 5. So 5 times 2x is going to give us 10x. Right, so we're multiplying each of the terms by 5. Because if we did multiply this by 5 here and we multiply by 5 here, we would have to apply distributive property. And so that's basically the same thing as multiplying each term by 5. So I multiply this term by 5 and I get 10x. Multiply this term by 5. 5 times negative 3 is negative 15. So I'm going to write negative 15. And it's a y, so y. And then here it's 10. So 10 multiplied by 5 is going to give us 50. So I'm going to write 50 right here. So now I can call this new equation equation 4. And then what we can do is we can eliminate, right? As with the name elimination, we can eliminate. So we can eliminate this 10x and this 10x. So what we can do is, we know that if we add these two equations together, like equation 3 and 4, if we add together 10x plus 10x, right? 10x plus 10x is going to give us what? 20x. It's not going to give us 0x, right? It's not going to give us 0. Instead, we can do 10x minus 10x, which gives us 0, right? This would work. Okay, this wouldn't really work. So what we can do is we can basically take equation 3 and 4. We can subtract this time, okay? You don't have to add the equations. Like in the other example I added, but here we're going to subtract because it works better. So I'm going to rewrite 10x plus 4y equals negative 16, and then 10x minus 15y equals 50. Subtract, so subtraction sign, like that. And then what I'm going to do is I'm going to subtract, so 10x minus 10x, right? It's just going to be 0, so there's nothing here. 4y minus negative 15y, right? 4y minus negative 15y. Remember, there's a negative here, and there's a negative here. So we must be careful. So we have two negatives here. So 4y minus negative 15y is the same as 4y plus 15y, because two negatives make a positive, and this is going to be 19y. So this here is going to be 19y. And then here we have negative 16 minus, don't forget the negative, 50. So negative 16 minus 50, right? Negative 16 minus 50 is going to give us negative 66. So this is going to be negative 66 right here. And now, just like before, we are left with one variable, and we could just solve this. So we can recognize that this is 19y, the same as 19 times y. So if it's multiplication, the opposite is going to be division. So we are going to divide both sides by 19. 19 and 19 cancel, and y is going to be equal to negative 66 over 19. I just moved this negative right beside the fraction, and there we have it. We can't really simplify this, so we have our y variable. So now that we have our y variable, we can plug it back into one of the equations and basically solve for x. It doesn't really matter which equation we plug it in. I mean, I think this might be easier, equation 2, because we have a lower coefficient in front of the x. So we would divide by a lower coefficient, right, when we isolate for x. So why not we plug it into equation 2? So I'm going to substitute y back into equation 2 so we can solve for x. So I'm going to sub y equals negative 66 over 19 into equation 2. So I'm going to copy equation 2, which is 2x minus 3y equals 10. So 2x minus 3y equals 10, as shown right here. And I'm going to plug in, and I am going to plug in this y value into the y here, okay? So I'm going to copy 2x minus 3 times y, which is this whole thing here, negative 66 for 19, right? I'm just copying this right here, plugging it into y, replacing the y with this because y is equal to that, and then it's going to be equal to 10, just copying this part. So now from here, we can see that we have our x here, and we want to isolate for x, okay? First, we're going to simplify this here, this fraction times 3, and we can't simplify it. As we can see, when we multiply it here, there's nothing we can really simplify. So I'm just going to go ahead and multiply to 3 and 66. I'm just going to copy 2x. So I'm going to copy 2x right here, right? And then minus 3 minus 66. 3 times 66, right? I'm going to go ahead and multiply that together. It's going to give me 198, and we have 2 negatives here, so it's going to be a positive, right? 2 negatives, make it positive. So positive 198 over 19, as shown here, and this is equal to 10. And then from here, we can isolate for x. So here we have a positive, right? We want to basically get rid of this from the side where x is, right? We want to keep x on one side all by itself. So that's our goal. So I'm going to basically recognize this as positive, and that the opposite of positive is subtraction. So I'm going to subtract this, right, from this side so we can get rid of it. And whatever I do on one side, I must do on the other side. So I subtract this here and here. Okay, same thing here and here. I apply it on both sides of the equation to balance it. So here it's positive and negative, same number, so it's going to be 0. And then here, you can copy 2x, so it's just going to be 2x is equal to 10 minus that fraction. And from here, we can recognize this 10 as being 10 over 1, right? Let's simplify this first. So I know this is 10 over 1, so if I recognize that as 10 over 1, I can basically multiply this, right, to get a common denominator, which is 19. So I'm going to multiply 1 times 19 is going to give me 19, so I can get the same denominator, multiply by 19 here, and 19 times 10 gives me 190. This is all over 19 minus 198 over 19. And then from here, right, I'm going to divide by 2 later. I'm just going to simplify this fraction first. So still 2x. 190 minus 198 is going to give me negative 8 over 19. And then from here, I have 2x, right? I want to get rid of this 2. It's being multiplied to the x, right? Because 2x is the same as 2 times x. So I'm going to divide both sides by 2, basically apply the opposite, so I'll divide this by 2, and I'm going to divide this by 2. Dividing by 2 is the same as multiplying by a half, right? Because the 2 is in the denominator just like this, so it's the same thing. And this 2 is going to cancel, and then this x is going to be equal to negative 8 over 19 times a half, and that's basically here. I'm going to copy this here, and I'm going to realize that I can simplify this, right? 8 and 2, they're both even numbers, so I'm going to divide the top and bottom by 2 to simplify it. And 8 divided by 2 is going to give me 4. It's negative 4 over 19. 2 divided by 2 is going to give me 1, so it's just going to become 1. 1 over 1, and that's the same as, well, 1 times negative 4 over 19. It's just going to be negative 4 over 19, right? This is 1. 1 over 1 is 1. And there we have it. We have found our x. So x is equal to negative 4 over 19. And we have found our y as well, as shown before. Right here, it's equal to negative 66 over 19. So thus, we can conclude this. X is equal to negative 4 over 19, while y, as shown before, is equal to negative 66 over 19. So negative 66 over 19. And we can rewrite it as coordinates as well, negative 4 over 19, comma, negative 66 over 19. And that's it. Alright guys, this is the end of my video. If you enjoyed it, feel free to give it a big thumbs up. And furthermore, if you are new to my channel, feel free to hit that subscribe button, and also let me know in the comments down below what you think about this video. Anyways guys, I hope to see you next time for another math video. Bye!